Hello, welcome to this short video. Today I would like to present NFL Big Data Bowl 2023 Group 7. Start with introduce the group mate. First, Muhammad Nu'man Haris bin Roslan. Second, Muhammad Izami Ashraf bin Ruzaidin. Third, Muhammad Ihsan bin Ros Azmi. Fourth, Muhammad Haikal Iqbal bin Hamidan. Fifth, Ahmad Ajwad bin Azmi. Start player state using tracking data. We stated the information about us. We are students from University Technical Malaysia Melaka. I would like to begin by giving greetings to everyone. This notebook gives an overview of a key set of statistics computed using player tracking data to determine season average for players. These statistics are intended to offer an idea of player inherent skill. Need one explanation and code inspired the construction of this notebook. Still, the emphasis is on the game from week 5. Input 1. Import pandas as PD. Import seaborn as SNS. Import matplotlab.pyplot as PLT. Import plot.ly.graph_object as GO. Next, load 1 week of player tracking data and PFF scouting data. Input 2, the data that have import in week 5. We can see the week 5 on the right side screen. This is all the data from week 5. So, declare the input week 5 at here, then continue with score and then play, players and games. This all must be included in this code because in week 5.csv file have all input data that shown declared here. So the data are read in CSVS. Let's merge this data into one set. Output 2 have shown in this area. 109781328 are the output. So, we go through the ball snap indices. Input 3, get ball snap indices. Declare _ID XS. Enter the event, ball snap and frame ID. To get 500 millisecond of movement after snap, get 5 rows. Each row is 100 millisecond of info. Declare X and ID XS. First, X equal IDXS plus X for X in range 0 to 6 for IDXS equal item for sublist in X for item in sublist. The output X is a list of lists. So this is just to flatten the list. Filter for snap pass 500 millisecond of data only using our selected indices. Declare also _DF with IDXS. Input 4, this part take from the week 5 file. So as we can see on the right screen, we enter the GID in this row, game ID, PID are from play ID, NID equal is from NFL ID. To produce the table, put the game ID, play ID and MFL ID. We can see the output in the table as shown 5 to 10. This is shown all the information from the code above. In the above example, we can see there are only 6 rows for a player on a given play. This will be the ball snap row and 500 millisecond after the ball snap. Line of scrimmage. Input 5. Get line of scrimmage info to compute block or rush deep relative to LOS. First, _LOS, we select the team, football and frame ID by entering game ID, play ID and X. Because we want line of scrimmage in input and merge SLS info back to the subsetted data. Input 6, define game ID, GID, play ID, PID and MFL ID, NID. For the output, the table shows that the value of line of scrimmage LOS are shown in last column. So, the preceding cell illustrate the determining the line of scrimmage from the X position of the football in the first frame of the play. Alternately, you might utilize the player's dataset under the column absolute yard line number, which should also contain information about the line of scrimmage. Using the same gameplay player example as previously, the last column in the data frame is LOS, which stands for the line of scrimmage. If you scroll to the right, next we go to different from line of scrimmage. Get different from LOS for all frame and players. LOS underscore different because we want to find the difference equal X and LOS multiply by -1 for plays going the left direction. This is so pass block is monotonic in the same direction as well as pass rush. Merge onto play info to get position team. Could do this anywhere. I do it here for no real optimal reason. Define the game ID, play ID and position teams, and then we merge. Input 8, define game ID, play ID and NFL ID. We can see in the output 8, loss different are shown in the last column. We construct a different from the line of scrimmage measure names LOS DIFF and verify that the offensive player are moving to the right and defensive player are moving to the left using the play direction features, and the -1 multiplier arbitrary whether the offense or defense is going left or right so long as they are going the same way for all rows. In another example, we can see that we have integrated some player data information, position team, and the final column in the dataset is the loss difference feature. Speed and acceleration data. Input 9 indicate if a player is on the position team, declare 1, the defensive team declare 0, or neither the arcade the football -1. So post team equal 0, position team and post team equal 1, team football post team -1. Create the initial snap speed data frame, means of speed and acceleration per player. Snap speed, S for speed, A for acceleration. Input 10, snap speed dot head. Using the group by technique, we take the temporary data frame we have been working with and aggregate the speed and acceleration data. Initial snap speed data frame contain NFL ID and average, S and A values. This is for the different speed and acceleration data. Input 11, given whether the offense player or defense player aggregate by the maximum or minimum LOS difference respectively. Example, if all linemen has more a negative loss difference, they allow more pass, rush, penetration. We define all the input data and then merge LOS different data back onto the snap speed. This time, S for snap S, A for snap A, and LOS different snap LOS difference. And then we can see in the output data, we have the snap loss difference in the last column. This provides us with new tools for analyzing player abilities. Furthermore, data analysis with snap speed data. Declare the df_plt and then enter the input NFL ID, official position and display name. Not forget to define the T, G, C, DT and TDE for the plot graph. X, Y and HUE are the axis line. So, using our snap speed data frame, we are able to observe which defensive player crossed the line of the scrimmage faster and which player blocked near to the line of scrimmage. It should come as a no surprise that following the snap, tackles who line up of the line of scrimmage are often further away from the centers who line up virtually on the line of scrimmage. Some defensive and appear to be able to cross the line of scrimmage more frequently than others. Perhaps they are better at timing the snap or simply get over the line without the getting called offside. We can also see the offensive player speed have no actual association. Perhaps there exists a defensive association. Faster defensive player can penetrate deeper beyond the line of scrimmage. Let's examine the DE list, sorted by the line of scrimmage differential. Defensive end player statistic. Input 14, declare DE_states and enter all the inputs. Output 14 shows the snap loss different are shown in the last column. The value different in each other. The value is different with each other. Recent Pro Ball and all Pro teams indicate that the number of the best player, Bossa, Martin, Ford, and other than that, perhaps the lesser known players on this list are underappreciated and undervalued. So, that's all from us. Thank you.